So just waiting here for the New York folks.
Yeah. Hello, Luis.
Hello. You guys have a web camera?
Yeah. Do you have a picture? Hey,
right.
how are you?
Ferran.
Yeah.
Oh,
Yeah.
look who's here. I'm here.
Hey. Do you want to see our students?
Hello, everybody.
This is Luis, and these are the guys. That's the second one. How are you?
Salam.
Salam.
All right, guys. So yeah, this is going to be kind of a brief session. You've already seen Grasshopper?
Yes, actually, we have already have a Grasshopper tutorial. So we checked the recorded session. It was almost the same thing that we work with the students.
Okay. Well, the thing is that I wanted to do this live as well for the New York participants. So it's just going to be kind of a repeat, a live repeat. So I don't know. I mean, of course you can listen to it and be connected, but it's up to, yeah, it might, I don't want to bore you.
It's going to be the same Grasshopper tutorial session, right?
Yeah.
Okay.
I'm just repeating it. I'm just repeating it for New York because we have a few other things to discuss as well with them.
All right, so we'll be waiting here for you for the start of the session.
Okay. I hope you don't get too bored since we already know everything.
No, it's all right. No worries.
Okay. Very good. Very good.
All right.
And great job
Okay.
on the stuff on Facebook. The images are looking really interesting. I saw you guys were already working with processing and such. So that's
Yeah, that's right.
I'm excited to see what comes out of there. And
yeah, because these guys, most of them know about Grasshopper, and we have some C++ and C# code writers here, so we are more or less familiar with this. Yeah.
Very good. Very good. So yeah, tomorrow I believe. Let me just make sure I look at the schedule without saying things that's not accurate. But yeah, so we'll do another tutorial kind of in the morning that if you guys want, you can also be connected to live, which will look at sort of processing the data that the students have been working with the smart citizens. So if if you're interested, we can send you some of the data so that you can also be working along with that information. In the afternoon, we'll be doing another tutorial on digital site analysis. We're going to use a new version of this plugin for Grasshopper called Heliotrope. We have a license from the creator. He gave us a license for us to use during the summer school. So I'll send you this information after this tutorial today, so we can all be using the same add-ons. So that's going to be coming tomorrow. On Thursday, we'll have some time in the morning for our participants here to do some work, but then in the afternoon we have a lecture, and then we have a kind of a presentation of the analysis stuff that we've been doing over here. If you guys want, you can also have well, we'd like you to join us to see what we've been doing here, but we'd be interested as well at the same time to see what you guys have been working on over there. So this will be on Thursday. Yeah.
So we're going to have a presentation of what we're doing on Thursday, right?
Yeah.
Okay, great.
Exactly.
Okay, so we'll try to post some news about daily activities too on our blog.
Very good. So yeah, let me see if I can track down these New York people, and then we'll get started.
Okay, so we'll be waiting.
Cool.
So, ciao for now.
Ciao for now. All right, so it seems like New York is coming online.
Okay, we're ready.
Oscar, can you see and hear us?
Yes.
Very good.
Hello, Luis.
Hello.
Good morning. Can you hear us?
I can hear you guys just fine, yes. Can you hear me okay?
Yes. Very good.
Very good. Can you see the screen okay?
Yes. Should I open my Rhino?
Yes, just give me a little bit of insight. Have you guys used Rhino, and have you guys used Rhino before?
I've used Rhino. I've been using it for about maybe 3-4 years, but I haven't used it for the past like maybe half a year to a year, so it might be a little rusty.
How about Grasshopper?
Grasshopper I've never used.
Excellent, excellent, great. I'm excited to get you guys to try it out and play around with it. How about Philip? How's his Rhino Grasshopper?
Yeah, I've used the both. I tend to work with 3ds Max.
Luis, we're thinking of sending you a meeting, like the meeting through my iPad, so we can work on my desk on my laptop. Would that be better? Because I don't have a double screen on the laptop.
Yes,
Like,
that's okay. Yes, yes. I mean, how you can connect as well on your iPad, right?
yes, I'm actually logged on to it. I see the meeting here for 9:30. So if I join it, I could probably cancel this one.
Yep. Okay, give that a try. See what happens.
Yeah, I have an app for the iPad.
So Oscar and Philip, this is a bit yak. You see in the video.
Can you see? Okay.
A bit of an industrial kind of warehouse. Some other guys. This is Dori. Taran. This is Meran. They're helping us here with summer school. Now our students are actually out on the town measuring some stuff. So I wanted to take this opportunity to have a session with you guys. So yeah. Hombre.
Por aquí, ¿dónde están las actividades?
Están en la ciudad y estamos conectados aquí con Terran y con Nueva York.
¿Puedes decir algo o estás hablando con él?
Estoy a punto de hablar con él. Luego hablamos.
Luego hablamos.
Okay. 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 Okay, guys. So sorry, I didn't get Philip your experience with Rhino and Grasshopper.
Yeah, no, I don't have much experience with either.
Okay. Okay. Cool.
Yeah.
All right. Well, I hope that the session will serve as being informative and kind of introduce you to the interface and you know, maybe also why we would want to use something like this kind of a way of working. Okay. So are you guys ready with the presentation and the laptop to use Rhino? Yes?
I'm trying to
I didn't hear. Aha. All right. I got you guys, but you're muted.
Am I muted?
There
I'm
it is.
muted.
I unmuted you.
All right.
I think I have the ability to mute you and unmute you. And anyway. Cool.
Oh, thanks.
Luis, is it fine if we use Rhino 2004 with the Grasshopper plugin?
Rhino 4, yes. Were you able to install Grasshopper for Rhino 4?
Yes, I installed it this morning. It worked fine.
Okay, yeah, that's no problem. Okay. Later on tomorrow, the tutorial we're going to do is using a plugin that I'm not sure works on Grasshopper for Rhino 4. I think it does, but we'll test it out and I'll let you know well beforehand.
Okay. What type of plugin is it?
It's a plugin to do some kind of solar analysis on different kinds of geometry on buildings and such. So it allows to set like the the location on the planet, and it gives.
Okay, so is it similar to the way that Ecotech operates?
Yeah, but it doesn't do. It's a little bit cheaper than Ecotech. Let's say it doesn't do diffuse solar radiation. It just does direct radiation, but it does it okay. It does it in a decent way.
Okay. So is this tutorial that we're watching today more of an introductory then?
Exactly. That's right.
Yeah. Okay.
Yeah.
Right.
Right. So all right, guys. Whenever you're ready, just let me know.
Okay. Ready?
Yeah, I'm just trying to get this thing done.
Okay. Yeah, you can start now.
Okay. So, what I wanted to, I guess, show you is a little bit of why Grasshopper exists, how we start to use it, and its relationship with Rhino. I don't want to talk so much about Rhino because which is not typical. I mean, I usually start with a decent introduction to Rhino, but then and then go to Grasshopper. But I guess what I wanted to get into directly is just Grasshopper. But let me first talk about why it exists. So let's just go over here in the front viewport.
Okay.
And let's draw a control point curve. Okay, so I'm going to choose control point curve with the left mouse button. It's going to ask me where I want to start the curve, and essentially I'm just going to draw four points, something like this. Yeah?
Okay.
Now, because I drew this in the front viewport, and it was using the XZ coordinate system that the viewport has tied to it, and if I look at it in perspective, obviously the curve is kind of sitting upright, no?
Yeah.
With most of its coordinates on the x-axis being 0. No? So it's just a flat curve, etc. So what I'm going to do, I'm going to copy this curve, and I want to make a loft surface from it. Okay. I'm going to select the curve over here, and Philip, maybe I'll I'm sure if you've used AutoCAD and things before, Rhino is pretty straightforward.
Yeah.
Actually, it's just it's a pretty natural extension, I feel, and it's really where I think AutoCAD starts to I mean, now AutoCAD is much better at 3D. I have to say that for sure. But 5-7 years ago, it was still kind of still not so nice to work in 3D, in my opinion. But
yeah.
So I feel that Rhino is a good extension of AutoCAD when you start really working in 3D. And if you are used to the command line and things like this, well, Rhino eventually has a great command line. But also there's a minimum 3 ways of doing anything. We have the command line, we have the buttons, and we have the menu. So, and anytime you use the menu or the buttons, you see what the command is that comes up. So, very similar stuff. But actually, Rhino was a plugin for AutoCAD. It used to be a plugin to open different kinds of file formats. So, so this is where it started, and then it just kind of was rolled into its own software package. So, in any case, I am taking this curve, which is a control point, and I'm going to copy it. And we can copy it, again, you can imagine command this copy here and here. So I'm just going to type in copy. And now if I just keep reading the command line, it just is guiding me, telling me where do I want to copy it from, and then some other options. But now I'm just going to click freely, just click a point, and make 2 copies and press enter to finish the command.
Okay, so did it copy it because it's sort of offsetted? So is there a certain distance that is offset at, or is it?
Yeah, I mean, all of these distances and numbers you can set in the command line, but I've just kind of done it by clicking. So now I'm just clicking in some position, and I'm moving over in Y, and just doing it kind of by hand. But yeah, all of these things you can eventually control. If I said, okay, well, I want to copy this from 0, 0, 0 to, let's say, 0, 20, 0.
Yeah.
And it'll make a copy exactly
20
units away. In any case, I'm just going to do it imprecisely now, just kind of eyeball it, okay? So in order to make this a little bit more interesting, I'm going to take my middle curve, and I'm going to edit its control points, okay? Just to make it a little bit different than the 2 end curves that I have here. So to do this, I'm going to go over here to the point on command, and this allows us to either on a surface or a curve to turn on its control point, so we have access to it to be to edit it. Just one thing to note: Rhino excels at NURBS topologies. So NURBS is fundamentally different than a mesh topology, where things like 3D Studio and Maya really excel at creating mesh geometry. Rhino takes the approach of using NURBS for non-uniform rational B-splines to eventually create surfaces and things like this. So it's a different, let's say, topological paradigm, which isn't necessarily that one is better than the other. It's just you have different possibilities with one over the other. In a mesh, you have really, a mesh is a list of points and sort of somewhat of a map of how those points connect together to make faces. Whereas a NURB surface is a much more continuous thing. You can't say that there's a certain, let's say, it's completely continuous from one end to the next. And this is what we're going to do here with this loft. Okay. So I'm going to take my middle curve, and I'm going to turn the control points on. So these are the same control points. All the curves are just duplicates of each other, so they have the same control points. When we started to create this curve, let's kind of go back here for a second. By default, Rhino's creating a degree 3 curve. Okay, and if I don't know if you've ever dug into this kind of stuff before, but really the degree is just kind of setting up how the control points influence the shape of the curve. Okay, you see that only the start and the end of the control points are actually on the curve itself, and the other 2 control points are off the curve. Well, let's say that I had drawn, instead of a degree 3 curve, a degree 1 curve. And don't worry about doing this, it's just a little bit more of a theory behind it. This is now a degree 1 curve, which looks a lot like a polyline, and actually it is effectively a polyline. There's no continuity between the segments of the curve, just besides the fact that their control points are at the same position. No? If I did the same, but changed this to a degree 2 curve, but use the same control points.
All right, then it should look like, you
can kind of see that we've changed a bit the influence of the control point on the curve, and we can continue increasing this. This is now a degree 3 curve. If I try a degree 4 curve, let's see what happens here. you see that it's going to be the same as the degree 3 curve. This has to do with the number of control points.
Okay.
The maximum degree of a curve needs to be the number of control points minus 1.
Okay.
Totally unimportant, but this is just a little bit of a background of
understand.
Rhino and things like this, and essentially why the control points that we see here on this middle curve are off of the initial curve. Sorry, Brad was just checking in here, making sure that's right. Anyhow, so what I want to do now is I want to edit these control points, and at this point, the control points are kind of considered like any points, so we can move them and translate them in space. So what I'm going to do, I'm going to select this control point, and I'm going to run, and actually here in the front viewport, I'm just going to move. Actually, instead of the front viewport, let's do it in the perspective viewport, and it'll just outline a few more topics here in Rhino. I'm going to select it. I'm going to say MOVE to move it, which is also over here down to the left in the main bar.
There is a command that you can do. You can set up the quick commands for just like cat, like polyline and copy and erase.
Yeah. Yeah,
you know
this is called an alias. Okay. Aliases you can set up. Let me see here. I think it's in the tools and options. Yeah. My options are going to look a little bit different because of I have Rhino 5 here. But if you go to Rhino options and aliases,
I see. Okay.
you have all of these other, and you can keep adding, etc.
Oh.
So yeah, this is a way that you can sort of customize your experience in Rhino. Now, I don't know. I'm a bit dumb in this regard, but I don't actually change this too much because I seem to be working on like 3 or 4 different computers at different places. So if I export my settings and bring them over, then you know the whole thing is useless. And by the way, some of the computers I use in some places, each night they get reflashed. So any settings that were there are gone anyway. So it's kind of I was really trying to do this for a while, but then it just decided to kind of forget about it. But I mean, things like the zoom extents and the zoom selected I use constantly because they're always there. But yeah, just to keep in mind, if you're only working on your installation of Windows and you know that never changes, then these aliases are fantastic. Okay. So back to this here. I'm going to move, and in this case, because I want to move this point vertically, I have an option here that's almost like a hyperlink that I can just click on, and it'll toggle whether my movement's going to be vertical or not. Okay, and vertical is relative because right now I'm working on a construction plane that's oriented on X and Y. So vertical here is what we would normally consider as Z. Okay, but if you're on a different, it's based on the coordinate system you're working on. So if I were to change the coordinate system, vertical would just be whatever Z is in whatever construction plane I'm using. This happens to be vertical here. I haven't changed it at all. So I'm going to just click on vertical and set it to yes. And then I can just click somewhere. And now my movement of this curve, of this control plane is constrained to be in the Z axis.
Okay.
This can be, you can write a specific distance. All of this you can control, but I'm just kind of doing it here by eye. I'm also going to take the first control point and I'm just going to drag it, click and drag it away. You can also move things by clicking and dragging them, etc. So I'm just doing that to edit this a little bit, so the middle curve is a bit different. Now, you notice that if I'm in this control point mode, I can actually select the curve itself. So if I press escape, I get out of that. Now I can go back to the object level and select the curve itself. Okay, so again, points on, you can modify the control points, and eventually to get back to the curve itself, you can press escape and you turn the point off. Okay, so really my point behind all of this was to eventually create a loft. Okay, so I'm going to select my curves, a loft creates a surface, so that is typically what we have to start thinking about is, okay, well, the surface, and the command was probably somewhere around the surface menu, if you didn't know the name of the command, but in this case, the name of the command is quite straightforward. It's just loft.
Okay.
So if I clicked on loft,
Oh, wow.
and if I had my curve selected, you get this nice, smooth NURB surface. You also get some options. This is kind of just a preview of the resulting surface. You haven't finished yet because there are several different commands, different kinds of lofts that we could do. If you want to just try a few, for example, if I just chose straight sections here and said preview, you see the kind of loft it would create. It would create a discontinuity here in the middle, and would just have a, you know, the edges. It would actually create a poly surface. It would create two different surfaces that would be joined together.
And what was the other one that you, the first loft? Yeah, that one. What's that called? Is that just normal?
That's going to use
more of a.
Yeah, it's going to be more continuous. It's using the curves as just guides, and so it's going to try to make a surface that's continuous through those guides. It's similar to what we were talking about with the curve. No, the degree 1, degree 2, degree 3.
Yeah.
If you go to a straight sections loft, that's kind of like a degree 1 surface, let's say. It may be continuous. It may be, you can think of it that in one direction, if we look at it like this, it's degree 1. But in this other direction, it's maybe a degree 3. Surfaces can now have 2 dimensions, whereas the curve that we were having before, we can only consider one direction for the continuity. So when we did a degree 1 curve, that was a segments. Here, because we have 2 dimensions, we eventually have maybe in one direction a 1 degree continuity and in another degree. But this is getting way more ahead of what really we're talking about. I'm just showing you here that we have several different options.
Okay.
And really, the one that I want is just the default one. Nothing more than this.
Yeah.
Okay? And
what are the other options that are available, such as closed loft and split tangents?
Yeah, so you can try this. If I said closed loft, you would see that I would try to make like a kind of a tube from this. But it would be a really strange thing because at one end, my curves are kind of all in the same axis, the endpoints. So it just creates like a kind of a sock with a strange seam here. You know? If we had different geometry, for example, like maybe other kinds of curves, we would try to create a closed surface from this.
Okay.
Actually, the loft command is quite extensive. It has a lot of different options. The options down here with the cross-section curves, this is more so like if you have some curves with a lot of different control points. We have a nice loft now because essentially the curves that I created come from one base curve that I've copied and I've edited. So they all have the same number of control points. The curves are the same degree. So we create a nice loft. We don't have too many problems with it. But it could be that somehow the curves that you're using for the loft are coming from different operations. They have eventually different control points, different degrees. And so when that situation occurs, you have a few different options in order to rebuild kind of the base curves. And then you go forth and make the loft. In this case, we don't need to simplify them. We don't need to rebuild them or align them. They're all already kind of coming from the same curve. So we already by default generate a really nice surface. And this is something to keep in mind when you're operating in really any CAD program. It's we're dealing with a topology, so the way that we drew the curves are going to eventually influence the way that the surface is generated. And eventually, actually, this is something we're going to see in Grasshopper. But what I wanted to show you now is if I say OK here, and this is something that is going to be much more visual in Grasshopper, but right now we're just seeing this kind of geometry for geometry's sake. But actually, all of these pieces of geometry have directions. We drew the curves with the control points in a certain direction. Maybe I started over here, then over here, then over here, then over here. And because of that, and because of how we've lofted, the surface itself has a certain direction. It's pointing actually down in negative z for some reason. And this is all topologically connected to how you draw the curve itself. So this is something that's going to come out later in Grasshopper. Okay? But we always have to be aware, and most of the issues in that I kind of come up with in Rhino just deal with how I draw the base geometry. And if I eventually can go back and fix the base geometry somehow, then my resulting geometry turns out much better. So it's a little bit difficult to detect now because we have some very basic stuff, but really many of the issues that arise in modeling in Rhino are really topological. How the sequence of events that brought you to the geometry you're using eventually generate that geometry. So the direction and things like this I don't want to worry too much about. My point here is, okay, so we've built this loft. We've done it from these 3 section curves. Now what happens if I take my initial curves and I move them around? Okay, well, the surface doesn't update, you know? And I'm talking about like Maya or 3D Studio. This is you get this by default in a way. Maya is using what's called the hyperstack. I think it's called hyperstack, but it's essentially a sort of a logical tree that is generated with every operation you make. You can't necessarily operate on this logic tree, but by default, the curves are the parents of this loft. So if you've changed the curves, then the loft as well changes along with it. But this is not the case by default in Rhino. If we change the parents, which are the curves in this case, the loft isn't going to update at all with us. Okay.
Okay.
Now, as of Rhino, I believe Rhino 4, they implement something to sort of bridge the gap and allow designers to set something like this up, set kind of this relationship up. So I want to show you this, but I also want to show you why it sort of is limited, quite limited, and this is really where we start to discuss why Grasshopper would be relevant. Okay, so for now I'm just going to delete my surface. If I wanted, if I wanted to have the surface now with these curves, I would have to loft again, et cetera, et cetera. So every time I change the parent objects, the curves in this case, I have to make a new loft. Okay. Now, down here.
So I see. Once you've deleted it, it doesn't actually delete the lines themselves. It just deletes the surface.
Yeah, it's just like there's 2 sets of objects. There are the curves and the surfaces. The surface is generated from the curves, right? But once I finish the command, I can move the surface somewhere else. I can move the curves. There's no association between them. They're just disassociated elements once that happens. Okay. So as of version 4, they created here. One second here. There was a chat here. Okay. Sorry about that. So as I mentioned, and as of Rhino 4, they implemented something. If you can see all the way down here at the bottom of the screen, this record history. It's along the same area where we have all of the other modeling aids, such as OSNAP and orthographic drawing. It's over here. It says record history. Do you see this?
Yeah.
Okay. So this allows us to sort of connect, allows Rhino to sort of keep track of some of the inputs you give to some of the functions. So if we say record history, the only indication that this kind of mode is turned on is just that record history is in bold like that. But so what's going to happen now is if I have that command, I run that command, turn the record history mode on, I select my curves, and then I run loft, everything looks the same. No, I mean, I create the same surface, I create the same from the same curves, but now what's happened is that Rhino is remembering that I use these curves for the loft. So I can move this around.
Oh,
And my surface is updated with every change of my parents.
so that only happens once you press record record history.
That is correct, yes. Okay.
Oh, because it's not shown highlighted at the moment.
Right. After you run the command, you can actually work, if you right-click on record history, you can set it to always record history. I'm going to try to convince you that it's quite uncomfortable to work in this way. Because let's say that I had done this, and I had maybe made up the surface, and then I was going to send this to you guys so that you could work on it, I don't know. Obviously here, this would be something more complex with other operations, but let's say that I had sent past you this file, and you said, okay, well, Luis had created the surface, great. Now I want to operate on the surface, but I don't like that the surface is here, so I'm going to move it over here somewhere else. Well, this is what would happen. We'd get this warning that says dragging broke the history on one object, okay? Because I've changed the child. I haven't changed the parents. Okay?
Oh, okay.
History in Rhino is just one directional, okay? You cannot change the child and expect the parents to update.
Oh, okay.
There's, besides the fact that I had done this, you would have no other indication this kind of information isn't recorded anywhere. You wouldn't be able to know that unless you started to play around. So that's why I find it quite limiting. Also, another thing is that not all of the commands in Rhino are history enabled. Only, let's say, like maybe, I don't know, 30% of the commands are history enabled.
Okay.
So those two things combined make it for a really kind of a clunky way of working. It's nice for certain things, but this is, it's very limiting, let's say. And if you really want to go crazy, just turn on always record history, and you'll realize very quickly that it's not a feasible way to work. So this is really where Grasshopper comes in. Grasshopper is exactly what I define as what's missing with the record history. It's a visual modeler, a visual, let's say, logic modeler, that what you're actually doing is instead of modeling geometry, you're modeling the process or the logic that generates that geometry. Okay? So I want to use the same sort of loft example as a test to show you how you would do something similar in Grasshopper. We'll start in a very basic manner.
Luis,
yes.
I have a question. In my loft, my plane, they're not aligned with the curves. Exactly, it's a bit off. How would I do it so they can be tightly bounded to the curves?
So what do you see?
I see my plane, like the...
Yeah, it basically looks like it's connected to the two endpoints rather than the middle point. So it's just going straight from the first to the third rather than through the second.
How can I share my computer?
Does it look like a candy wrapper? Like a candy with two? Does it look like this? Hold on, let me I try to show you.
How can I?
Does it look like?
How can I share my desktop?
Yeah, what I can do here is I can make you the presenter, and you can share your desktop so I see what's going on.
Okay.
See, I have my plane.
Yeah, it's not that true. Third one, is it?
Yeah, but it's not really bound to that.
Okay. In this case, can you? I'm going to ask for. Okay. Say okay. Okay. This is because you've chosen the loose option. So try to run delete the surface, and so delete the surface. Run the command again, but before you hit OK, notice the options that you're using.
I select the both.
So look at the style here, loose,
Oh yeah, click normal.
and switch to normal.
Okay.
And now say OK.
Oh,
Oh, okay.
So yeah, the loose and tight also kind of change how the curves eventually influence the resulting loft. So normal loft is yeah, we'll attempt as best as possible to go through the curves you choose. Okay.
Okay.
But yeah, I mean, my point here was that if you didn't choose record history, then if you change the curves now, then your loft is going to stay there. It's not going to update, right?
okay. Louis, from this point, is it possible to add another curve to the geometry of the surface so that you can change a different point on the actual curved surface?
You're saying to add a curve or to switch one of the curves for another one?
No, to add additional ones along
Yeah,
the surface.
no, you'd have to recreate the whole loft. You'd have to loft it again.
Oh, okay.
Like this.
Yeah,
These
like
are the
that.
kinds of things that Grasshopper allows you to do. So with Grasshopper, yes, it is possible. Without Grasshopper, it's not possible.
Oh, okay. That's what I meant is that putting ones
Yeah.
in between
Oh, putting one.
in between ones that already exist that you can change, sort of make it certain details.
Okay.
So yeah, these are the kinds of limitations that I was talking about. I mean, I say limitations, but I mean I use Rhino as my main modeling tool for all sorts of projects. But I guess I just want to kind of sell you the idea that these kinds of things, like okay, now I want to add a curve, or now I want to do this. These are the kinds of things that in Grasshopper you can do without too many problems. You can say, okay, well, actually now I want to add 2 more curves, and the loft is just going to automatically update with these new curves.
Okay.
Okay. I'm going to take back the presentership.
Okay.
Okay, guys. I'm sharing my desktop again now. Okay, so let's run Grasshopper now, and I'll show you how we can do the same thing.
Put the audio off over here.
Whoa, we have some feedback.
I'm trying to turn off my audio.
Okay. I won't be able to hear you initially, but anytime you want to talk, just say something. Okay. So to run Grasshopper, we use the command Grasshopper. So because it's a plugin, what plugins eventually do is to add new commands, new functions to the Rhino system. So if I say Grasshopper, it should detect something, and if I press Enter, actually, I already have Grasshopper open, so you're going to get something like this. And what, actually, check.
Yes.
Can you see something? Okay. Yeah, somehow now, yeah, this seems to work better without the echoing. I don't know what it was before. Maybe it was the other. Check. It's the seems to be the other one that's. Anyways, now I can hear you and you guys can talk and there's no echo. Okay. So in Grasshopper here, what we see in front of us is, I'm just going to kind of define first a little bit the interface. Okay. This area over here is what we call the canvas. Okay. On the canvas is where we're going to be drawing and setting up our what we call definitions. Definitions are the, let's say, aggregation of components and the way that they're connected together in order to create geometry. Okay, so in a similar way as to how we've selected the curves and then run the loss command, I want to do the same thing, the analog to that here in Grasshopper. Okay, so we have to think. Well, first of all, I should find something that allows me to create a surface. Okay, and here, Grasshopper is made of several, a whole bunch of components. Okay, these components are organized in a similar way as how they're organized in Rhino. So, for example, eventually, if I want to create this lost surface, it's probably its command is probably going to be here in surface. Okay, I have several other component areas, which are just actually add-ons, like plugins for Grasshopper. So you might not have these yet, but don't worry about that. You should probably have the components up to transform. And when I say components, it gets a little bit tricky because, of course, we can think of an architectural component like a facade element, or a structural element that we could say, oh, this is a component of this part. But here, what I'm going to try to stick to the nomenclature to say that the component is the function, the different elements that we can utilize to create geometry. Okay. So let's get your first component on the canvas. Okay, this is going to be, let's say, 10% of the things you need to learn to eventually use Grasshopper. Okay, so getting components on the canvas is quite simple. In this case, I know that I want to make a loft, so I'm going to go over here to surface, and I'm going to start to look around and see where this could possibly be stored. Okay, here in surface, we have all of the components that eventually would allow us to compose and decompose surfaces. We can also analyze them. For example, if I want to find out the surface area, or maybe if it's a closed volume, I can check its volume. So I have all sorts of different options in terms of analysis. I can create primitive surfaces, and what's called here primitive is essentially any kind of surface that can be generated not necessarily from other geometry. So here, for example, a sphere you can create with an XYZ coordinate and a radius. Okay, you don't need to take a bunch of arcs and loft them together to create a sphere. You can define them parametrically with this quantities and positions. So what we're talking about is something a little bit more complex, and it's actually what's organized under here as freeform. Okay, which is going to be a lot.
Would it have to be I don't know, put into different layers so we could start, or does it do that automatically? Like, so I don't know, just in case you want to.
What do you mean different layers?
Like in Rhino, you have here layer 1, 2, 3, 4.
Yeah.
I know every object you can choose it to be a different layer, so you can later on turn it off or not,
yeah,
or hide it.
In this case, we don't need to deal with layers just yet.
Okay.
Okay. Eventually I'll mention layers here in a bit, but I'll discuss that as we go along. Okay.
Okay.
I wanted to mention that Grasshopper. I think it's kind of important to note. McNeil itself, the company that makes Rhinoceros, is a company made up of about 80 people. Okay. So compared to, let's say, Autodesk, that has so many products, I don't know how many employees. I can imagine close to 1,000 employees. I don't know how many employees Autodesk actually has, but it's a much smaller company. But it's interesting that being so small, actually the support that you get from the company in case you have any technical issues is quite good. And specifically, Grasshopper is written by one person, essentially. His name is David Rutten. He created Grasshopper during his 2-week Christmas vacation in 2007. It's something that he did kind of in secret. He developed it for a while just on his own, and he eventually showed it to the people at McNeil, and they realized very quickly that this was something that was a really interesting way to work. Okay, so before I just wanted to mention that, and now I'll show you a little bit of how this actually works. So eventually I said we wanted to create a loft. So I'm going to go to here, surface freeform, and loft. I'm going to click once. That menu goes away, and I click again, and I eventually put this little component onto the canvas. Okay. And I'm going to talk a little bit about how we read this component, what's going on, and how we can learn to use it. Because if you learn to use one component, no matter what its function, if you learn to read what it's asking you for, then you should be able to use almost 90% of the other components without any issues. Okay. Now, a few things. You probably see your components like this. It says loft, no?
Yeah.
Okay. So I prefer to work with the icons of the components, and to do this, you can go to Display, Draw Icons, and it'll switch to the icon mode. I think it's actually more helpful to work in icon mode. I know that you might think that it's helpful to see what the command is, but after we get so many different commands on the canvas, then it gets even less easier to read with the text. So I prefer to work with the icons.
How do I go again to the icon recovery?
It's here in Display, Draw Icons.
And what's the other way of viewing the component other than an icon?
Yeah, you can have it here. I can turn Draw Icons off, and you see the text.
Yeah.
So you can either work like this so that all of the components, have their text, or if we go to Display, Draw Icons, it'll draw the icons like this. Okay. Now this component, at the moment, is expressing that it's not so content with us. Okay. We're not giving it any information, and thus it's giving us a warning. And this is why we see it as orange. Okay. When we see the component here as orange, it says, something's wrong. I could still try to generate something, but something weird might happen. I might be generating something that you don't expect. Okay. In this case, it's not generating anything because you're not giving it any curves. Thus, it's not just going to imagine what curves you want to use. It's not going to assume that. So we need to feed it some curves in order to make it operate. Okay. Now let's take a look at some other stuff here in the component. Okay. All of these components are, let's say, hover sensitive. Okay. So any place we can hover over several different areas. So for example, I can hover over the input, the C, for example, and we get some information. I can hover over the middle, and I get some other information, and I can hover over the other end and get some other information. So all of these zones, if we just hover our cursor, we're going to get some information out of them. Okay. In this current state, the component has this little speech bubble, this little cloud over here.
Yeah.
And if we hover over there, it says, it tells us this warning. It says, input parameter C failed to collect data. And that's just a fancy way of saying that, yeah, C, this area over here, C, that eventually is what we call an input, doesn't have anything going into it, so it cannot create anything. And if we look at L, this is actually the output, the result of this operation. So the output eventually is going to be some kind of surface. But right now it says empty bref parameter, meaning that it's not generated anything, and it's giving us a little bit more in-depth information. And this also deals with the nomenclature of Rhino and Grasshopper. This bref that you're seeing there, that stands for Boundary Representation Object. Okay, and this is it's a different way. It's a kind of a topological term for a surface or a polysurface. It's an object that's represented by boundaries, by edges. So if you see bref, just don't think of anything else besides surface or polysurface. It's just a technical term for a surface or a polysurface.
Okay. So there are no surfaces or polysurfaces for it to create lots from.
It's essentially, that's the result. So it's going to result in a surface or a polysurface, depending on how you have the options of the loft. Okay, and it's just it's like a hierarchical term. So a surface is a one-faced D-rep.
Yeah.
A polysurface is a multiple-faced D-rep.
Mm-hmm.
Okay. So here, both surfaces, the terminology surface and D-rep are used. Whereas in Rhino, you have surfaces and polysurfaces.
Okay.
But all of the terms are talking about the same family of objects. So another thing to note are these little icons that is next to loft. So you see this kind of cylinder there that's next to the word loft.
Yeah.
All of the kinds of, we should start thinking about all of the objects that we draw more as objects and less as their kind of geometry. So we should think about, when we created this loft, that loft was created from curves. And those curves were created from points, eventually, or positions. So there's a whole, let's say, topological gradient that goes from a single one-dimensional element to eventually what we see as a three-dimensional object. These surfaces or curves or points eventually can be decomposed into their more basic elements. So if we decompose a surface, eventually we would get out of that its edge curves, maybe its endpoints if it has them. If we decompose a curve, we eventually would get its control points, so on and so forth. Much like a word is actually composed of letters, okay? A sentence is composed of words. So we should think of more of our objects as information that can be decomposed into its simpler forms. I just mentioned this because eventually this might be relevant, but I digress. What we need to do here, what's missing from this logic, is just the information to tell the curve, the component, what curves are we going to use in order to create this loft, okay? We have 3 perfectly good curves in Rhino that we've drawn, right? We've already drawn them in Rhino. So I want to show you now how to take these curves in Rhino and link them with the logic in Grasshopper, because right now, Grasshopper doesn't know that these curves exist, okay? In the same way that right now, it doesn't know that these curves exist. So we have to tell Grasshopper to consider these curves in its solution. So how do we go about doing this?
I have one question.
Yeah?
What does the O stand for?
Okay, the O, that's a good question. The O are the options for the loft. Do you remember that when we run the loft command in Rhino, we get this window of options?
Yeah.
It's the same thing, except that we can set them in Grasshopper in a slightly different way. So actually, if you right-click on the O, there's an area here called Loft Options.
Okay.
And you see that we have some similar kinds of options. We have the closed loft, the aligned sections, and then the different kinds of lofts that we also have available to us in the loft command in Rhino.
Mm-hmm.
So it's just an area where we can actually set those options. Right now, what I want to focus on is not so much the options, but this C input. So if we just hover over that input, you see that, first of all, we get that icon for curves. So we can immediately know that, okay, we need to feed this guy with some curves. And it's asking us for these curves as a list because it needs more than one curve to create a loft. So what I want to do is I want to bring these curves that I have in Rhino into Grasshopper. So to do this, and this is going to be true with any kind of geometry that you would eventually have already in Rhino and want to associate with Grasshopper, we would go to Params, this first tab over here all the way to the left. And here in geometry, actually are all of these icons that I've been discussing that are kind of showing us the kind of geometry that we can use. So here, actually, we want to focus on the curve parameter. So I'm going to click here and click on the canvas. And we get a slightly different looking component with this curve icon. So what this is going to do, it's also orange because it also doesn't have any information, okay? What this is going to do is it's going to allow me to connect and reference a curve that I've drawn in Rhino into my grasshopper definition. Okay, so let me show you how to do this. I'm going to right-click in the center of this component here, and I'm going to say set one curve. I'm going to scroll down or move my mouse over where it says set one curve. Eventually what I'm going to do is I'm going to click on this. Grasshopper is going to go away. You're going to get a sort of message on the command line to choose the curve that you want to reference. And as soon as we choose the curve, we're going to get Grasshopper back. Okay? So let's try this. I'm going to right click on the center of the component. I'm going to go to set one curve. Grasshopper goes away. Now it's asking me here the curve or the edge I want to reference. So I'm going to click on the first curve. And you see that eventually Grasshopper comes back. Another thing to notice is that the component is now no longer orange, it's gray. Because it's satisfied, it has some information, and we can now continue and use that somehow. How did this work for you guys?
Yeah.
Same.
Yeah? Okay. Good, good. So, although it's a bit redundant, what I'm going to do is I'm going to bring down one of these curve components, one for each of the curves that I have in Rhino. Eventually we'll see that this is not necessary. If you notice, actually, in the right-clicking, in the center of the component, there's set multiple curves. So we could actually reference multiple curves with the same component, but just to point out a few things, I just want to have one curve component for each of my curves that I have in Rhino. But of course, if let's say we had 100 curves we wanted to reference, this would be completely tedious to do it like this, one by one. So in the second component, I'm going to right-click, set one curve, and in the third component, I'm going to right-click, set one curve. So now all of my components are gray.
Sorry, when you right-click, what option do you select?
I'm choosing set one curve.
Set one curve. Sorry,
Yeah. And then I'm choosing the next curve over.
Okay.
Oh, right there. Okay.
So for each of my curves, I have one curve component. Now you notice that if you select the curve component, first of all, the component turns green, but then you have some kind of reference on the Rhino viewport of which geometry you're selecting. Yours is probably green.
Mm-hmm.
Yeah?
Yes.
Exactly. And I mean, I quickly get tired of these default colors, so I've changed mine to be gray and magenta. Eventually, I'll show you how to change the preview. That's not so important at the moment. But the important thing is that you see that when you select the components on the Grasshopper canvas, then that signals in the Rhino viewport. It gives you a kind of a preview of what that is.
Yeah.
Yeah. Okay. So our lonely lost component still doesn't have any information because we haven't done one of the most important things in Grasshopper, which is to make the connection between one set of components and the other. Okay, this is really a major part, and it's what Grasshopper is really all about. Okay, so what I'm going to do, notice that in each of these components we have these little semicircles. Okay, and if I hover my mouse over, my cursor changes to an arrow, kind of an arrow with a kind of a cable or something coming out of it. And if I click and drag, I can extract a cable from this output. And this cable wants to go to some input, so it snaps to input. In our case, the input we want to go to is the curve, the C input. So I'm going to bring it over, snap it to the C input, and just let go. Okay. Were you able to make the connection?
Yes.
All right. So somehow, and I think this is a bug in, I think maybe in your case, is the loss component gray or is it a different color?
Great. Yeah.
Okay. It probably shouldn't be. I think this is a bug but it should probably still give us a warning because you can't make a loss from a single curve.
Yeah.
Okay.
You need multiple curves. And actually, if you look at the output, if you hover your mouse over the output, you see that the resulting loss surfaces is null.
Yeah.
So it's generated some result, but the result is invalid. It's null.
Well,
So what I
yeah.
need to do is I need to connect several of these curves into the C input. But as you start trying to do this, you notice that it doesn't allow you to do that. It's just letting you connect one thing at a time. Okay?
Yep.
Well, it's not so difficult to fix that. Actually, what we need to do is and I'll take this opportunity to also, to just show you that you can actually connect more than one element, more than one input into this. So now, if I do the same thing, if I drag the cable out, but instead I press Shift, you notice that my cursor now turns green, and it's allowing me to connect more than one thing to the input.
Okay.
And by the way, you'll notice in your Rhino preview that we have some kind of surface started to be created here.
Mm.
How would I delete one?
So if you want to remove the connection, you can do the same thing, but now with Control.
Okay.
Shift allows you to aggregate a connection. Control allows you to remove it.
Okay.
You can also do the same if you right-click on the input and say Disconnect.
Oh, okay.
And you can see there how to disconnect it. You'll notice actually also that if we right-click on the input for the curves, we did have the option to actually reference all of the curves directly into that input. Right now the option is grayed out because that input is inheriting information from an external source. Okay, so we can no longer reference geometry into that input because it's getting the information from somewhere else. It's inheriting the data. If we didn't have those connected, we would have the options to set the one curve or set multiple curves, and we could do that directly with the loss component. But I'm using this to show you what Grasshopper is about, and it's about really connecting components to components. Another reason that this is smart here is, let's say that you wanted to do something else with the curves later on. Well, you have access to them. If we were to reference the curve directly into the input, we wouldn't have access to those curves, actually. They would just be stuck inside here. Now try to connect the third input, and you'll see that you generate that lossless surface. So Philip, this goes back a little bit to what you were saying about, okay, what if I wanted to add a curve to the system? Well, I mean, here you're kind of doing it. Now I'm adding the third curve. And you could imagine you could have subsequent curves here, like if I copy this. You can have subsequent curves. We'd have to, in our current system, kind of keep referencing new curves.
Once again, if you were to use one of the curve components as a reference for all the curves you've drawn in.
Exactly. Yeah, we don't need to do this. So now let's see how to do the multiple now. So with the same, I'm going to bring down a same version of the same component. Now I'm going to right-click and I'm going to say Set Multiple Curves.
Right.
Okay. Now we're going to go. It's going to go to Rhino. It's going to say the same thing. So it allows us to now pick multiples.
Oh.
Then I press Enter, and I get the same result.
All right. What if I wanted to add an additional curve in between two existing?
Well, you could either, let's say, choose it here and shift, add it like we did shift before, or you would re-reference the curves. So let's say I had another one here that I've added. I have to go right-click, set multiple curves, and choose the curves again. Does that make sense?
Yeah, no, but I meant in between, instead of extending it, if I wanted to add one in between two curves that already exist, for example, the first curve in between the first and the second curve.
Yeah, if I had something like this.
Yeah.
In this case, and I'll discuss eventually in the subsequent tutorials the topic of data management, okay? Because here, in this component, notice that, first of all, we have this kind of cable, which is a double cable here.
Yeah.
Okay? And before, when we were working with these other curves, we have a single cable. Okay? The single cable means that we're transmitting one thing. One anything. It could be one point, one curve, one surface, one mesh, one anything. Okay? So it's a single solid cable. The moment that I have this double cable, it means that I'm transmitting more than one element. I'm transmitting a list of objects. Okay? There's actually one other cable type we'll see a little bit later. Okay? So why I mentioned this is that effectively what we have here, in my case, I have 6 curves that are referenced here. If I wanted to add another curve, I have a few options. I can either right-click and reference them all again, okay? Or I could somehow reference the new curve, and I could figure out with some data management components how to just insert this new curve into the list of curves before I go into the loft, okay? So the data management stuff is here in sets, and we have a bunch of components to work with lists and to, particularly here, like list insert. So I can insert something into another list. But I don't want to get too deep into data management just yet. This will come in the next couple of tutorials.
All right. Okay. But that would be effectively that's the method in which you'd add additional.
Yeah, you would modify the list of curves first, and then bring that into the loft.
Okay.
And we could do that with, for example, this list insert component. You could take this new curve, for example, and insert it into the list of these curves.
All right.
In any case, what we have now, and if I actually reference, I have something kind of interesting here because I created this curve here last. So if you kind of can see my visualization, it's almost as if it transitions the curves here and then goes back to this end curve over here. And it's because I created this curve, I created it last after all of these curves, plus I did a kind of a strange thing, but when I said multiple curves, I did a window selection. When I do a window selection, Grasshopper is going to give you those objects in reverse order to which they were created, okay? So it's not actually assuming that you want the curves in the orientation according to Y.
Yeah, it's just the position when you added them.
So if you want to control this, what you need to do is be conscious and not do a window selection, but select the curves one by one. And then Grasshopper is going to return that list in that exact order, and eventually the loft looks like this. Again, if, let's say, we had 1,000 curves, we're obviously not going to pick each curve one by one. Eventually there, we have some kind of other ways that we can reorganize this list. We could, for example, sort the list according to the Y coordinates or other ways. But this, again, this is part of the kind of data management things that we can do with the Grasshopper data management tools that we'll see a little bit later on. But that's almost 50% of the things we need to know. I mean, the first 50% we're going to learn today, and the next 50% deals with data management, which is quite an important topic here in Rhino, in Grasshopper. Okay, so we should have some kind of loft. And actually, I'm going to go back and just choose my initial 3 curves to make something a little bit more appealing. I'm just going to choose these 3. I'm going to get rid of my other curves. And you see, because I deleted some of the curves that were referenced here, now they're orange. It says, hey, you deleted the curve that I was keeping track of, so I'm going to change I'm going to give you a warning. Anyhow, the important part is in what we're doing over here. Notice, by the way, that of course, if we change our curves, the loft is always going to be generated along, just updated, okay? It's going to continuously update if I change my curves.
Oh, is that because of its, because that was done in Rhino, in Grasshopper?
Grasshopper gives you this for free. This is what we do when we connect one set of elements to another, okay? It's every time that we change the curves, we're changing what's happening in the reference, and that is always going to update the loft component. So we don't have to remember to do to define record history. It's always, this is essentially what we're doing. We're always recording history. So a couple of things you might notice though. This loft, try to select it in Rhino. It actually doesn't allow you to select it. It doesn't exist in Rhino yet. It only exists in Grasshopper, and what we actually get here is a preview of the geometry. Okay, and Grasshopper is really working like this because it's trying to, because it's agile and it updates, it's always trying to draw the minimum amount of stuff in order to be as fast as possible. So also you might notice, I mean, in my case, I have kind of a very rough representation of this loft, kind of faceted here. And again, these are just some quick shortcuts that Grasshopper takes in order to be able to be quick. If we try, for example, to render this, my render is going to give me nothing because I don't have actually any surface geometry or any geometry to actually bounce any rays against. It doesn't exist yet in Rhino. So let's say that we had modeled the best surface ever, that we were very happy with the surface, and now we wanted to maybe export it to a different program or wanted to actually do some other things with it in Rhino. Well, what we do in that case is we select it. We select the component that is generating the geometry that we want to utilize or export or something. We right-click in the center of that component, and here we have a few options. First of all, we have options for previewing, so we can turn the preview of that off. We can turn it on, and this preview is only hiding the geometry. It's always going to calculate the geometry. It's just hiding it from view. We also have the ability to disable the component, and in this case, the geometry is not being calculated at all. And finally, we have this kind of fried egg icon. And this fried egg icon next to it has bake. So baking is what we do when we eventually want to, use the geometry in Rhino or export it. So I'm going to select bake, and we're going to get a little option there. And this goes back, Oscar, to what you were talking about in terms of layers. We can bake this geometry, the surface eventually, onto a specific layer if we want. We can also change the display color, the display type. We can do a few different things. I'm not going to do anything by now. I'm just going to have it land on the default layer. But if I say OK, notice that now I get my surface in Rhino. I get a slightly strange visualization in Rhino because now I have my Grasshopper preview geometry as well as my Rhino surface on the same spot. So it has a bit of an issue to visualize this properly because it's trying to draw the same geometry in the same place. Okay. But anyways, we can select now the surface, and I can move it somewhere else, right? And you'll notice that it's as smooth as possible.
So which is the Rhino one?
Say that again, Philip.
Which surface is the rhino geometry?
Which surface is the rhino surface?
Yeah.
It's this one. If you select it and click and drag away, you should see it's essentially the surface you can select. Can you select some surface?
Luis, we're losing you.
Yeah.
You can select the surface, yes? Can you move it around somewhere?
Yeah.
Okay. So this is the surface that exists in Rhino. Now, try, for example, to change the curves. You'll notice very quickly that this surface that we've baked is no longer associated with the logic that we have in Grasshopper. So it's kind of disassociated, it's frozen, it's parametrically dead. Okay, it's disconnected from all of this. But in exchange for that, we have some geometry that we can eventually render if we are in the proper viewport, proper view. So it's over here somewhere now. But yes, as soon as we bake something, it is disassociated with the logic of Grasshopper. But it allows you to export it to run different commands in Rhino, etc.
Oh.
So baking happens when you're saying, okay, I'm done with this model, I'm done with this logic. Now I want to, make some nice images and, eventually operate on the geometry in a slightly different way than in Grasshopper. Okay, so, but of course, our Grasshopper definitions are going to be a little bit more elaborate than this. Right now, essentially, we have two components. And what I want to do is I want to continue this a little bit and show you what else we can do now that we're in Grasshopper, just to kind of expand the example a little bit, okay? So what's nice about Grasshopper is that now that we've created this beautiful curved surface, this infinitely continuous, we can subdivide the surface into infinite points, infinite resolution, and we can always have, take advantage of this continuity that it has. With this kind of situation, let's say that I wanted to now populate the surface with some kind of geometry, okay? Let's say that I wanted to use this curvature of the surface to our advantage and orient geometry along all of the curvature that we have here, okay? So what I'm going to do is I'm going to go back to surface and I'm going to look at what options I have here to generate some references that give me, that are based on the surface. So I'm going to try to find some kind of way to create a reference that later on I'll use to populate some other kind of geometry. So here in Surface, I'm going to go to Utilities, and I have a component here called Surface Frames. Okay, this component is going to let me create these kinds of references. So I'm going to go to Surface Frames. I'm going to click it, and then click again onto the canvas. Okay. Now I'm going to go from the lofted surface. I'm going to connect from surface to S. So from L to S. I'm going to go L, S. And if you do that correctly, you'll notice that the component itself turns gray, which is curious because we haven't even put anything in U and V, right? I mean, we've just fed the component with what it wants here in S. It wants a surface. It wants to divide the surface into a series of construction planes. Okay, and notice that if we zoom out a bit in Rhino, we have a construction plane already here, and it's identifying the x-axis and the y-axis. And what we've done here with our surfaces, we've actually generated many of these construction planes. Okay, and these construction planes can serve as orientation planes for other kinds of geometry. Again, if you didn't know how this component worked, and we had just dragged it here, if we hover over the inputs, you see that this component in S is asking us for a surface to divide. Okay, do we have a surface? Well, maybe we have a B rep that is actually one face, so that actually is a surface. So I'm going to connect from L to S, and that satisfies what it's asking us for. So it says, great, you gave me a surface. I know what to do with it now. I'm going to eventually subdivide the surface into a bunch of construction planes. Now, notice over here, the U and the V. If you've ever done any sort of texture mapping, you might recognize U and V from that. And U and V are essentially defining the two dimensions of the surface, right? The surface, imagine that, obviously from our perspective, we see the surface in 3 dimensions, right? In our 3-dimensional world, the surface has curvature, it's traveling up and down, etc. But now try for a second to imagine that your world, the world that you live in, is on this surface. If you live on the surface, you don't know what is up and down. All you know is forward, backwards, left, right, diagonally, etc., etc. You actually are constrained to the surface. You don't know what an offset is. You don't know what Z is. You only have U. You can only travel in U and V coordinates. Okay. So from our perspective, it looks 3D, but a surface can actually be considered as a 2-dimensional object. And this is what U and V are sort of asking us for. They're asking us, how many divisions do you want in the U dimension, and how many divisions do you want in the V dimension? Okay. And by default, it has an integer number of 10 and 10 in both U and V. And I know it's an integer by the icon that is in the input, okay? This icon is just kind of this 7, but it's just trying to signify a whole number. So here, what it wants as inputs are whole numbers. And you'll notice that some of the components have some default values already inside of them.
Okay. Oh, so the number 7 doesn't change. That's just telling you that the number has to be an integer.
Yeah, the number 7 is just an icon. It doesn't actually define that it's actually a number 7 or the value of 7. Inside of there, actually, if you hover over, it's actually 10 by 10.
Oh, yeah.
This is the actual value that's in there. The icon of 7 is just an icon for an integer. A little confusing, actually. But, in any case, I want you to try now modify these values and input a different value for U or V. So I'm going to right-click on V, and I'm going to say set integer, and very carefully I'm going to move over to this new panel that it pops up, and just put in, I don't know, 30. And once I hit 30, I'm going to eventually select commit changes. And you'll notice that in the U direction, it's now subdivided into 30 parts. So I generate many more construction planes in the U direction. And I can try this again with the V direction. I can right-click on the input V. I can go to set integer. Did I do that in V or? Oh, I actually did that in V, sorry. I'm going to check the other input, U in this case. I'm going to go to U, set integer, and I'll try 50. So now I'm generating so many construction planes that they're overlapping each other, and it's hard to see an individual frame. So that's one way that we can enter values in there directly. Now that's fine, but we actually don't know what the values are. The only way that we would know is if we hover over the input and see what actually you had entered in there. Okay. So I'm going to introduce you now to a few more ways that we can input these numbers. So here I'm going to go back to params, the first tab. Are you guys with me so far?
Yeah.
Yeah. Okay. Cool. So I'm going to go back to params, and I'm going to choose input, and I'm going to choose panel. So sorry about that. So I didn't see you. Arati, come over here.
Hello,
Guys,
Manny,
sorry.
Bernardo.
Bernardo doesn't see them, but
Okay.
we have Oscar and Philip in New York.
Hello, Oscar Philip. How is everything?
Guys, this is Arati. She's the Masters of Advanced Architecture Program Director, as well as many other things here at the she's also going to be with us during the Global Summer School.
Good to have you on board, and great to see that the problems were solved with Taran, and great to have two people in the One Lab workshop. So yeah, good luck, and we will be talking about the development of the project. Nice to have you here. Virtually.
Okay. So what I wanted to discuss here is to go to params input, and I'm going to try here panel. And a panel is a way, it's a multifunctional component. So we can actually use it, excuse me, we can use it to annotate our drawing. So I could double click it as it's telling me to just start to write. So I could say, hi there, New York City. This is a way to write a note. And I say okay, and it's so it's first as a way to annotate the definition. But we can also use it as an input device. I could just write number 30, say okay, and connect this to U and B. Right? Right now I don't see any difference, but if I switch this to 60, this updates. Now let me ask you something. Did you get the component turning red?
No.
No. Okay. Well, it's a very common mistake to have something like this happen. Okay, and let me just explain to you because it might pop up at a certain point. I did something while entering this number that I didn't notice because it's something that we do almost without thinking, very intuitively. But because I did this intuitive thing that I'll explain here in a second, the component is now confused, and it's a definite error. And when a component errors, it turns red, okay, as such. So when that happens, I have a little message bubble pop up, and it says error. Data conversion failed from string to integer, okay? Now what I've done, and what you haven't noticed, and what you didn't do, is that actually when I entered the number into the panel, I mistakenly pressed enter. And then I said okay, okay? And this action is just actually, maybe I'm the only one that does it, but it's just something I'm used to because in computer program paradigm, you usually enter something and you press enter, or on the internet, you enter something into a text field and we press enter. Well, now when we press enter, what essentially has happened is that the component, the frames component, is considering this as a kind of a text, as a kind of a paragraph, okay? So that's why the warning says fail to convert from string to integer, because a string is the name of the data type for something that deals with characters and text. So if you were writing your name, that's a string. If you're writing a sentence, that's what in programming languages is considered a string. So because I pressed enter, there's an extra value here, a new line, and it considers it a string. So the only way to fix this is to just make sure that the cursor is always next to the number and say okay. If you want to try to just activate this error, just so you can see, just enter this number in here and press enter and say okay, and you'll get the error. Okay, so just so eventually you'll I hope you don't run into it, but more than likely you'll probably run into it. So if you do that, and this is always something that you can. What's this?
Sorry, what happens if you input more than one number? So if you press enter and then type in another number underneath.
Yeah, it's still going to consider it a kind of a paragraph, and I'll tell you why. Right now, this is actually like if you, in Word, had written 60, enter 60. It's still considering, even though it's numerical characters, it's still considering it as one paragraph because we are not doing something here which is actually outputting a list of these two, okay? I don't want to get, this is something that I'll explain a little bit later on, but we can actually now get these numbers to come out as a list instead of just one thing. You'll notice here, if I don't do that, it's still giving me the solid cable, meaning that I'm still transmitting one element. So it's only transmitting one object, and this one object is composed of these four characters, and it doesn't know how to transfer this into a number. Okay, it sees 60, enter 70, and it doesn't know how to actually convert that into just one integer. It's not going to make any assumptions for you. So this is why we get this error. So for now, the best way to fix this is to ensure that we have one number and that the cursor is next to that number. I'll discuss a little bit later on the next subsequent tutorials how we can actually write a list of numbers. Okay, so this is one way that we can enter numbers. Another way is we can use here in params input the number slider. Sorry, I'm in need of a bit of coffee. So the number slider is actually something you'll probably use quite a lot, okay? Because here, still in the control panel, sorry, in the kind of the post-it note panel that we have, we always have to double-click, enter the number, and then press OK. So it still makes us sort of go into there, type it, and then accept that number. So the number slider, if we bring that down in params input number slider, we get this kind of weird component that has this little dot, and we can click and drag this dot around to choose different numbers. And the number that's displayed is the number that is output from, well, the output of the component over here. Notice something though. First of all, these numbers go from 0 to 1 by default, okay? The second thing to notice is that it has 3 significant digits after the decimal point, okay? So basically, these numbers are useless to us for what we need them now. We need actually whole numbers, we need integers, and we need them to be at a much broader range than just 0 to 1, okay? So in order to change and modify these parameters, I'm going to double-click on slider. And what I get there is a kind of options window that allows me to change the parameters for the slider. So for example, let's say that I didn't necessarily know how many construction planes I wanted in each dimension, but you know, I wanted to play around with it. I'd say, well, maybe I want no less than 10 sliders, subdivisions in one dimension, and I don't want to consider more than 100. Okay, so minimum I want to play around with is 10, maximum I want to play around with is 100, and by the way, I don't need such precision in my numbers. I don't need to deal with real numbers. What I want to deal with are just integers, okay? So I'm also going to go over here to rounding and change this to integer numbers. So again, I double click on the minimum and maximum and I change those to what I want them to be. And I press this little green check. I can also define the default numerical value by sliding around down here. If you like, you can also change the name of the slider. I can say, I don't know, number or divisions, something like this. And then I can say OK. So that's how we edit a slider. We go into it, we can change its minimum and maximum, and change the slider accuracy. And then we get a kind of a nice component which we can just kind of play around with and get different results. So I'm going to connect the slider now to V, not with shift, just regular connection. And you'll see that if I change the slider, it changes the subdivision of what I'm generating. I'm actually going to use it for both U and V. Do you get something similar to this? Hello, guys?
Yeah.
Yeah? Okay.
All
right, so,
my
yeah?
model comes out red. How do I change the color again?
Like the surface and such?
Yeah.
Okay.
Yours is gray and mine.
Yeah, do you have this little button here, document preview settings?
Yeah.
So click on that, and you can change here the normal and the selected color. So if you right click on, if you use this kind of color picker, you can choose different colors and also give it a little bit of alpha. So this is how it's going to come out normally, but then you also have the color when it's highlighted, when it's selected. So you can choose different colors here with this color picker. You can move them around like this or like this and choose what color makes you happy for. I choose kind of a grayish and magenta. Choose something also like light blue also works really nicely. But it also will make your Grasshopper definitions and screenshots stand out. It's like after, I don't know, it takes different people different time to get sick of the red and green color. And eventually they switch it on their own to something. It took me about 2 years to finally decide and say, okay, I can't stand seeing these two colors anymore, so I switched it to something else. Now for you, because you're in Rhino 4, actually, this is just changing the preview colors for this actual file. If you want every new file to switch, and maybe actually it might not have even changed them for you because there's kind of a bug in the version for Grasshopper for Rhino 4. It might not have changed them. But if you select everything you have on the canvas, you select everything there, and you press Control C, then you press Control N to start a new file, and then you press Control V, your colors should be updated in this, maybe not actually, because we haven't changed the default. Yeah, this is just something that the version for Rhino, for Grasshopper Rhino 4 doesn't have, didn't get updated. Here, I think maybe in File, you have the preferences, or in Edit, you have preferences. Or no, you have Window. Yeah, you have an extra menu here called Window, I believe. And there you might have the preferences. Is that correct?
Nope.
You don't have Window as a menu?
Nope. Yeah,
So you're on Rhino 4 or Rhino?
Rhino 4.
Are you on? You have Rhino 4 or Rhino?
Pretty sure it's Rhino 4.
And you don't have, okay, well, anyway. But the changing of the colors works?
Yeah.
Yeah.
Okay, sorry. Okay, I just had some students this morning that had some issues. Okay, sorry about that. Anyhow, let's finish this off here. So now finally, I have all these construction planes. Let's put something on there that's oriented to all of this, all these different orientations. You'll notice that construction planes here are normal to the surface at different points. So what I'm going to do, I'm going to put some cone on here, some kind of cones that are oriented in these directions.
You can barely see my enemy.
What's that?
Oh, because you have,
I have a lot of them.
yeah, we put 10. You put
My divisions is are 10 by 10. So, yeah, maybe it's best at the moment to lower the number of subdivisions because eventually we're going to generate some geometry on here, and it's best to start with a low number. So what I want to do is I want to put some primitive geometry on these construction planes that are coming out of F. So I'm going to go to Surface, Primitive, and Cone. I'm going to put some cones on there. And the cone has actually 3 inputs. It has the base plane, so the base construction plane. It has the radius, and it has the length, or the height. Okay.
Sorry,
So actually, yeah?
geometry. You use the geometry in the cone?
This
Sorry,
is surface.
could you repeat that? Can you go back to that?
Yeah, it's surface, primitive, and cone.
Okay.
Yeah, you see what that is?
Yes, got it.
Okay. So here we have to feed it properly. So in terms of the base plane, actually what I want to give it are all of the construction planes we're generating over here. So I'm going to connect from the F to the B. And we have a slightly different cable, but it's not to worry about this at the moment. I'll explain this later on. In my case, my cones are being generated, but they're very small. The radius and the length are in a very different size according to my surface. If I actually zoom in quite a bunch, I might eventually start to see the cones, okay? But I need to change the radius and the length to something that's a little bit bigger. In my case, I don't know what yours looks like. If you can you see the cones?
Where?
Maybe you can see them, maybe you can't. But what I'll do is I'll use my panel here, and I'll connect my panel to the radius and to the length. And maybe you can start to see some kind of cone. Do you get some cones in your viewport?
No.
Yeah.
Okay. And of course, if we were to go back and decide that we wanted some more divisions, I can just increase the number of divisions, and it would generate, you know, a cone on every one of those positions. Now, tell me something. Are your cones facing down like mine?
Yes.
Yeah.
Okay. So this is
ours are a lot bigger as well.
okay. Yeah. So kind of maybe it's just because we drew this curve kind of freeform, the initial curve for the loft. So just you might want to tweak your panels to have smaller sizes, because when we started the whole exercise, we freeform drew the curve, and you could have drawn it maybe 10 times bigger than I did. You know,
Yeah.
you know what I'm saying? So we didn't control this part. In any case, what's important to note is that my cones are also facing down. Now, why is this the case? We have to trace the whole, let's say, generation of the surface back to the initial start point, okay? And this is eventually why we will tease out why it's like this. So when I drew the curve in my front viewport, I drew it from left to right, okay? So the curve had a direction that's from left to right. I copied these curves. All of the curves had the same direction. Even if I changed their control point position, they still had the same direction. So when I locked the curves into a surface, the surface itself is going to be formed by the direction of these curves somehow, and it's going to take on a direction itself. So the surface has a direction facing down. So what I'm trying to say is, if I were to change the direction of my initial curves, I would then change the direction of my surface, and therefore I should have the cones pointing upwards. Okay, so let's try that, and we can actually try that in Rhino. So somewhere in this mess of geometry, if we just window select, we have our curves, right?
Yes.
Yeah.
We should only have
hide all the other pieces.
we shouldn't have anything else there. If you have surfaces, just delete them. We should only select 3 curves.
Yes.
Yeah. Now these curves have a certain direction, and I could flip this direction by using the command flip. And press enter, and notice what happened.
Yeah.
I changed the direction of the curves, meaning I changed the direction of the surface, meaning I changed the direction of the cone. So it's all topologically linked together.
Yeah.
Okay, so this is essentially where I wanted to get with you guys today, just as a kind of an introduction to Grasshopper. Yep. Do you guys have any questions? I know it was kind of a quick shot.
No, I mean, it's pretty straightforward. I think I understand everything.
Yeah.
Up until this point.
Thank you.
So what I would suggest you guys look at, I'm going to give you a link here to a nice site. One second here. It's digitaltoolbox.info. And I'm going to write it here in the chat. And this this website has Rhino and Grasshopper tutorials. If I were to go over here to Grasshopper Basic, for example, it has a bunch of video tutorials explaining, some of the things that we saw today, and it then goes on a little bit further to talk about different kinds of operations. Okay, so I would recommend that you guys try some of the examples here. Okay, again, they're video tutorials, so you can kind of follow a few along. The one thing to note is that Grasshopper changes quite quickly. I mean, it evolves every 2 months or so. There's a new version. So some of the things in the tutorials, maybe some of the components are in a different location, or maybe they have a different name. But anything you can do in the tutorials, you can still do in this new version. You're just going to have to work a little bit harder to try to find where the component might be, because the components change, the way that they're organized might change for some reason or another. So I think with the time you have here in the morning, I would suggest that maybe you try to go through a few of these. There's also the grasshopper3d.com website that on the front page you have this kind of link to the Grasshopper primer, which again is this is a PDF that you can download that explains some of the logic of Grasshopper. but it's also kind of a nice reference. It's also a bit outdated with regards to the current versions of Grasshopper, but still there's some useful information. So I would kind of look at these resources here, and yeah, just try to expand a bit on what we've done today. And what we'll do tomorrow is, well, actually the students are kind of coming back from doing some data capturing, data collection. And what I'll do is I'll send you guys some of the data that they've captured. And tomorrow we'll see how to bring this data in and start to use it as drivers for other things that we do in Grasshopper. So we'll kind of see how to read a file, how to work with the numbers in the files, and eventually create some very basic graphs with this information.
All right. What type of data specifically is it that they're collecting today?
So today what we've done is we've gone to I'm going to bring this up here in a second. So yeah, so our guys have gone to 6 different plazas in Barcelona, in the old city of Barcelona, because we're working on a project that in 2014 will eventually be constructed. This project was given to, I don't know if you know the architect Enrique Miralles.
Yes.
Yeah. So he's no longer with us. He died in the 2000s, I believe 2005, if I'm not mistaken. Yeah, I have to. But anyways, he started an office with his wife Benedetta Tagliabue. So they have an office called EMBT, and the city of Barcelona has given this project to Benedetta, and it's essentially next year will be the 300th anniversary. I think I don't know, maybe I spoke of this already, but next year is the 300th anniversary of the let's say in a way the loss of independence of Catalonia. So it's when Catalonia was eventually incorporated into Spain. So even though this is kind of a strange thing to celebrate, because the Catalans are very proud about their language, they're very proud about their heritage and their history, it's still important for them to remember this, and this is how they commemorate where they came from. And so this celebration will kind of commemorate liberty, democracy, diversity, and a few other kind of let's say important themes for the Catalan people. And so what she's been tasked to do is to create some architectural events, some ephemeral architecture in these 6 different plazas to sort of activate them during the event. And she's chosen to partner up with us for one of these plazas, and specifically the one we're working on is Plaza de Salvador Seguí. Have you guys been to Barcelona before?
Yes.
I haven't. No.
I have.
Okay. So the plaza is in an area called Raval, and actually in the plaza that we're working in, they've just built the new Filmoteca, which is kind of a film library and a film event center, which prior to this was kind of distributed around the city into different buildings. So Josep Luis Mateo, which is an architect in Catalonia, has just recently completed, let's say about 6 months ago, has completed the Filmoteca, and has just recently completed the plaza around it. There was a plaza here before, but let's say this corner is a notorious corner. It's notorious for a few reasons. First of all, when you arrive to Barcelona and the Raval area, at least personally, is an area that I really enjoy to go out, to socialize. There's a lot of like nice bars, and it's fairly, let's say, cheap in a way. It's low cost, nice bar, nice places to socialize. But it's also where a lot of, let's say, it has a bad rap because there's a lot of pickpocketers and this kind of things. And particularly in the corner that we're working with is historically been a corner where there's there's prostitution. The prostitutes sort of, it's one of the last spots in the middle of the city where prostitutes still congregate. And this is historical because eventually the cross streets led directly to the port. So this was, you know, the ships would come into the port. The people working on the ships would, you know, come into Raval to take their time off, and well, I don't know, one thing leads to another. In any case, the way that the city of Barcelona deals with these kinds of issues is extremely passive aggressive, but they're actually also quite successful. So they take an issue, they take an area of town that might be problematic due to crime, etc. And instead of trying to put more police or something, they create a project around it. They create a public space, and they create some kind of architecture that activates that public space. And this is one of the most recent examples, which is this Plaza de Salvador Seguí, with the Filmoteca. The same happened in Plaza del Ángel. This is this Richard Meyer MACBA Museum, the Museum of Contemporary Art, up here in Plaza del Ángel. The Arc de Triomphe was actually created to commemorate the destruction of the old citadel, which is over here. So this was also kind of a problematic area, and they took it was also part of the celebration in 1888 that they did it. So each of these locations has sort of been chosen because it's been an intervention by the city, a very intentional intervention to try to resolve some kind of issue. In any case, what we're doing what we're taking the opportunity to do with this summer school here in Barcelona is to generate different kind of proposals, prototypes, and ideas to activate the plazas in different ways. But more in we're trying to create productive prototypes with the activation of public space. So the students have been out today with this kit that we've generated here at the Fab Lab called the Smart Citizen Kit. It's a kit that is based on Arduino, which we'll look at a little bit more in depth later on in the week. Have you guys heard of Arduino?
Yes. Not really sure what it's about, but
this is great. I'm glad. I like when I can introduce these topics to people because they're topics that are, I think, for me personally, had a great impact on how I started to think as a designer. When I realized that, you know, I want to make eventually things reactive. I want to make my designs be able to take in input from the environment. And Arduino is a very easy platform that allows you to start to get into the basics of electronic engineering, and really takes a lot of the complex parts of electrical engineering that we don't necessarily want to focus on, and just allows us to access electronic engineering in a way that is very intuitive. So what Arduino is, it's essentially a piece of hardware and a piece of software. So the software allows you to program the hardware to do different things. It can take sensor input. For example, you could connect a temperature sensor, for example, and it could be telling you the temperature. And with this input, you could actuate things. So let's say that if the temperature is above 100 degrees Fahrenheit or 40 degrees Celsius, then turn on a motor to open up a window. Let's say this is a very basic example, but you have the capabilities to do this kind of stuff with just very basic program. You can write a few lines of code, and then you can generate something like this. So the Smart Citizen platform is based on this Arduino hardware, and it essentially adds on top what's called a shield. It's extra pieces of hardware that have other elements. So this shield, it's called what we call urban sensing shield, has an array of sensors. It has a microphone to read noise levels, okay, and which is primarily what some of the students here are interested in, to detect how noisy a plaza might be during different times of the day. It also has a temperature and humidity sensor. It has a light sensor, so we can also get the ambient light levels, and it has a carbon monoxide sensor and a nitrogen dioxide sensor, which are two key components to detecting the quality of the air quality. So it essentially takes all of these readings and it stores them, let's say, at whatever resolution you like. So let's say you can have this reading come back to you every minute, every 30 seconds, every second, and it's storing it on a text file on the platform. So essentially what we're going to look at tomorrow are these text files. So they're going to have a timestamp, and essentially it's going to tell us at this time the temperature was this much, the humidity was this much, the sound was this much, and the CO and the NO2 were this much. So we're going to get a reading for each point in time and each location in space, which is going to allow us then to be able to create graphs and to evaluate the differences in between the plazas. So the students today went to all the different plazas at different times of the day. They broke up into different groups, and they collected this data about the plazas. So tomorrow, what we're going to do is we're going to look at this data and start to see what are some of the, what kind of differences we can tease out with this information, and try to render this information. So what we can do tonight is we can send you some of these files so that tomorrow we can work together and have the same set of data. Now, what I suggested to Berardo is, because you don't have the Smart Citizen kit there available, and just to ask you to put together a quick Arduino kit isn't so straightforward. A lot of the things that the kit itself can do, record sound levels, record light levels, and these kind of things, we can actually do with our smartphones. There's several applications, and I don't know if you guys have iPhones or if you have Android phones. What do you guys do? Do you have something like this?
Yeah.
You have iPhones.
Yes.
So you can download some free apps on the iPhone that actually allow you to record the same data, but just with your phone. So you don't need like an extra sort of Arduino kit. It could, obviously your phone doesn't have a CO and NO2 sensor, and it doesn't have a temperature sensor, but you can record light, you could record sound as well. So this could be somehow combined to kind of render the locations that you're on. And one thing that you don't have, one thing that you do have that the kits that we have here don't have are GPS. So what you could do is you could actually go around your site and actually not just track the sound and the light at a certain time, but you can also get the location. For our purposes, we've had to write the location kind of on a map, and then we can extract the GPS location. But you guys, if you use your mobile phone with one of these apps, you could actually also track yourself, and as you're tracking yourself, you can track those other readings. So this could be an interesting thing. So,
Sorry?
Yeah?
You know what the name of the app would be?
I have to look in my, hold on a second, I had sent these to Mumbai. Let me see here. Yeah, mobile phone sensors. One of them is called Sensor Monitor. Let me copy it here for you, the link. And there's also something called Anti-Map. So here I'm going to connect you to Anti-Map. The thing is that I'm not sure if, let me see here, one second. How are you? No problem. So one thing is I'm not sure if Anti-Map has the recording of sound and light levels. Sensor Monitor does. So these are just, unfortunately I don't have an iPhone, so I can't tell you how these work, but I know that Sensor Monitor has the ability to record maybe light levels and sound level. Anti-Map and GPS. Anti-Map just records GPS and then like the let's say other the kind of accelerometers and other things on your phone. So I think maybe Sensor Monitor might be the best solution, and it also allows you to log this information and save it to a file. So this could be a way that you guys could also go to go around the Navy yards, record some of this information, and create a sort of a map of some of the forces that we don't just see visually with our eyes, but actually we can detect with other instruments.
Okay.
I'm also going to ask some of my other. We have a lot of assistants here that have come from that have just graduated that were actually my students, and a lot of them found other apps. So what I'll do tonight is I'll ask them to send me the links to those other apps so that you could get them as well. It might be useful also to check the iTunes store and maybe start searching for like sensor app or sound symbol or these kinds of things to see if you can find an application that is better suited for this. I think Sensor Monitor does this, but again, because I don't have an iPhone, I can't test it myself.
Great. Okay, thank you.
Yeah. So I think this is a way that we can work in a similar manner, even though you don't have this kit. But I think you have an added bonus that you can actually track your location with it. And this is what I actually made another kit that has a GPS, and it's really cool because now we don't have to worry about pointing this on a map. We can just walk around and we get the reading of the location.
Yeah.
Okay. So I think you'll be with Berardo this afternoon to work a little bit on this, and then we can come back tomorrow and we can discuss the processing of the data that we capture. All right, guys?
Thank you very much.
All right, thanks for your patience, and yeah, let's continue to keep in touch. We'll have several sessions coming up tomorrow.